So what we want to do is we want to start talking about limits and how to compute them. So we talked a little bit before about what limits are, but the idea is great. We have to actually compute these things. So let's talk about some basics. So first, we have to start somewhere. Let's just start with sort of two basic ideas, and that's just that the limit of the function x as x approaches c is just going to be c. So I think that's fairly straightforward. I think we can sort of get our heads around that. And the fact that the limit as x goes to c of the constant function 1, it's a constant, it's just always going to be equal to 1. We don't really have to worry about it. So the idea, the name of the game, is we want to try to compute more complicated limits from these. So how are we going to do that? We're going to use the limit laws. So how these are going to work is the following. This is the idea of taking a limit we know and using it to compute a limit we don't necessarily know. So the limit laws are very simple. They just say that if the limit as x goes to c of just some function x, let's just call it L. L, limit starts with L, why not? And the limit as x goes to a number c of g of x is equal to m, then, well, we have that a couple of things are true. We have that the limit as x goes to c of the sum of these two functions is the sum of the limits. All right, pretty straightforward. So if you have a constant, then we have that the limit as x goes to c of the function a times f at x is just going to be equal to a times L. Then we have two other quick facts. We have that the limit as x goes to c of the product of these two functions is the product of the limits. And finally, the limit as x goes to c of the quotient of these two functions is going to be the quotient of the limits if m is not 0. So of course we can't divide by 0. In that case, we'd have to have something different happen. So these are the limit laws, and now let's go through some examples where we use these limit laws to compute some other limits that are more complicated than these two up here. Okay, so let's go through some examples. So first, let's do a pretty easy one. Let us just do the limit as x goes to minus 1 of x squared plus 7. So what can we do here? Well, the idea is we take the limit laws and we use them to take this guy and we turn it into easier pieces. And what we can do is, first of all, we can use the sum limit law to break this at least into the sum of the limit as x goes to minus 1 of x squared plus the limit as x goes to minus 1 of 7. But then, now we can use two limit laws. X squared is the product of x and x, so we can use the product limit law, and this we can use the constant multiple limit law. 7 is 7 times 1. We're going a little slow here, but we just want to get used to the rules. So let's call that a constant multiple. So then this turns into the limit as x goes to minus 1 of x times the limit as x goes to minus 1 of x plus 7 times the limit as x goes to minus 1 of 1. But now we can conclude, because we know what this limit is, know what this limit is, and know what this limit is. So this just turns into minus 1 times minus 1 plus 7 times 1, which is just equal to 1 plus 7, which is equal to 8. And that's the answer to this limit. And how we did it is we just took this guy, and we were able to take him, who's a little more complicated, and then break it up into smaller pieces, and that's how we were able to use the limit laws to compute this limit. Now let's do another example over here. Something a little more complicated, but still something that we can just use the limit laws to just get through nice and easily. So let's try to take the limit as x goes to 0 of x squared minus 2x plus 1 divided by x squared plus 3. Now, what can we do here? We have a quotient of these two functions, and we're going to see as we go that the limit of both the top and the bottom is going to exist, and the limit of the bottom is not going to be 0. So what we're going to be able to do is we're going to be able to use the quotient limit law. And by the way, I'm just sort of putting in rough point form what limit law I'm using. There's no exact precise way of how to justify these things. There's no formal rules of you have to write it this way. I just want to give a rough indication of what we're doing, and I suggest you do the same when you work out your own problems. So we're just taking the limit as x goes to 0 of the top guy divided by the limit as x goes to 0 of the bottom guy. We know we can do this, so let's just proceed from here. So now, using a bunch of limit laws, I guess we're using sum, I'm going to be using product, and I'm going to be using constant multiple. We can just do the same sort of things we did over here in this one. We can say that this guy here, because x squared is x times x, this is the limit as x goes to 0 of x times the limit as x goes to 0 of x minus 2 times the limit as x goes to 0 of x. And this is a bit of writing, but indeed, we get what we get. And then the whole thing is divided by, we can do essentially the same thing on the bottom. X squared is x times x. We can break that apart into these two guys here. And then plus 3 times the limit as x goes to 0 of 1. And now we can just compute everything and be done. This is just 0 times 0 minus 2 times 0 plus 1 up top, and 0 times 0 plus 3 times 1 in the bottom, which of course gives us 1/3. And that's how we're able to take this slightly more complicated expression and just use the limit laws to break it into little itty-bitty pieces, all of which we can compute. Then we're done, and we move on.